You ever wonder why we use copper and iron in pots and pans? Well, the reason is they heat up actually very, very quickly with minimal amount of energy. Now, the equation that we chemists developed to actually explain this is Q equals mc delta T. So, let's go through this problem. Q actually stands for heat or energy. The units for Q are in either joules or calories, cal. M is just the mass. The units are in grams. Now, C actually stands for the specific heat. Now, specific heat is unique to each element or compound. What specific heat represents is how much energy it takes to raise 1 gram of a substance 1 degree Celsius. So, delta T finally is the change of temperature. It's either in Celsius or Kelvin. So let's use this in a problem to actually better understand it. How much energy is needed to increase the temperature of a 50-gram solution of water from 25 degrees Celsius to 90 degrees Celsius? The specific heat of water is 4.184 joules per gram per degree Celsius. Well, we know we're going to use Q equals mc delta T. What I like to do is actually write out each variable from the problem. So, mass is 50 grams. Delta T is 65 degrees Celsius. And the specific heat is 4.184 joules per gram per degree Celsius. Plugging this, and we're solving for Q. Plugging them into the equation, we're left with 13,598 joules. But looking at the problem, the lowest amount of significant figures is actually 65 with 2. So the Q gets reduced down to 14 kilojoules. Now, on your own, try this problem, and we'll go through this when we come back. How much energy is needed to increase the temperature of 50 grams of iron from 25 degrees Celsius to 90 degrees Celsius? The specific heat of iron is 0.11 joules per gram degrees Celsius. And when we come back, I'll walk through this with you, see if you got the right answer. All right, so we're going to be using Q equals mc delta T. We know the mass is 50 grams. The delta T is 65 degrees Celsius. Specific heat is 0.11 joules per gram per degree Celsius. And we're solving for Q. We put these in the equation, and we get 358 joules. Now, again, there's only the lowest amount of significant digits in the equation is 2, so it gets reduced down to 360 joules. Now, comparing this what we got to the water, it takes to increase iron the same amount of 65 degrees is only 360 joules. Compare that to water, which was 14,000 joules. So this is why we used iron for the cookware, is because it absorbs heat so easily and with minimal amount of energy needed.